The modern kitchen is a theater of deception. The home baker stands before a gleaming stainless steel machine, a device costing thousands of dollars, believing the modern oven is a tool of creation. The home baker mixes the flour. The home baker kneads the water and the salt with hope and precision. The anticipation builds as the dough rises. Yet, after 40 minutes of intense heat, the result is a betrayal. The loaf is pale. The crust is not a crust, but a thick, leathery hide that demands to be chewed rather than shattered. The interior is dense, heavy, and uninspiring. The bread is a failure. The modern baker blames the flour. The modern baker blames the yeast. The modern baker blames the recipe. But the modern baker is wrong. The blame lies with the metal box itself. The modern electric oven is not a bakery. The modern electric oven is a dehydrator. The modern electric oven is designed to strip moisture away and to murder the potential of the grain before the grain ever has a chance to rise. Contrast this failure with the reality of the year 1240. A village baker in medieval France did not possess a thermostat. The village baker did not possess a timer. The village baker did not have electricity. Yet, day after day, the village baker pulled loaves from a wood-fired masonry cavern that would put modern artisanal attempts to shame. These medieval loaves possessed a crust that sang, a golden-brown shell that shattered upon contact. The interior was an open network of impossible lightness. The medieval bread was not just food. The medieval bread was a mastery of atmospheric physics. The medieval peasant ate better bread than the modern millionaire. This is the paradox of progress. The technology has advanced, but the quality has regressed. The knowledge of how to manipulate heat and water has been traded for the convenience of a button. I'd consider the silence of the modern kitchen. When a modern loaf is removed from the electric oven, the loaf sits on the counter, mute. The loaf is a dead object. Compare this silence to the singing of the medieval loaf. When a true sourdough, baked in a steam-saturated stone chamber, is pulled into the cool air, the bread speaks. The contracting crust crackles, pops, and snaps violently. This is the song of the bread. This sound is the audible proof of a crystallized, shattering crust structure that modern appliances simply cannot replicate. The silence of the modern bread is the silence of failure. It is the sound of moisture that was stolen, not managed. Why does this happen? Why does a primitive stone chamber outperform a digital convection oven? The answer lies in a single, invisible element that the modern world has forgotten. The answer is steam. The industrial food complex does not want the consumer to understand the relationship between starch and water vapor. The industrial food complex sells preservatives and softeners to mimic what physics once did for free. The history of bread is not a history of ingredients. The history of bread is a history of thermodynamics. The medieval oven was a steam engine. The modern oven is a drying kiln. The modern consumer has been trained to accept mediocrity as the standard. And the supermarket shelf is filled with soft, plastic-wrapped rectangles that never stale, never rot, and never truly nourish. These are not bread. These are edible foams stabilized by emulsifiers. By accepting this standard, the modern human has lost the genetic memory of what grain is supposed to do. The medieval peasant, often depicted as starving or destitute, would likely spit out a slice of modern Wonder Bread. To the peasant, and the modern bread would taste of nothing but air and faint chemicals. The peasant understood that bread is the staff of life, and one does not forge a staff out of foam. We have traded the nutrition of fermentation and the physics of stone for the convenience of a plastic bag. This is not just a culinary loss. It is a loss of heritage. It is a severance of the bond between the human hand and the elemental forces of fire and water. This investigation will not simply offer a recipe. This investigation will dismantle the physics of the modern kitchen. This investigation will expose why the convection setting is the enemy of the sourdough loaf. The following analysis will explain the concept of starch gelatinization and thermal mass in a way that no cookbook ever has. The objective is to reclaim the lost engineering of the past. The objective is to turn the home kitchen into a laboratory of ancient survival. Consider the sensation of eating a truly great piece of bread. Yet the resistance of the crust, the shattering crunch, the soft, moist crumb inside. Now consider the last loaf produced in a standard home kitchen. Was the experience the same, or was the experience a disappointment? The disappointment is not an accident. The disappointment is a feature of modern appliance design. The modern oven is built to roast chickens and bake cookies, tasks that require drying. Bread requires the opposite. Bread requires a violent and humid environment that allows the dough to expand before the crust sets. The industry's secret is simple. Bread baking is an act of delayed structural hardening. If the crust hardens too fast, the loaf cannot grow. If the loaf cannot grow, the bread becomes a brick. The medieval mason understood this intuitively. The modern engineer has ignored this completely. By the end of this broadcast, the viewer will understand exactly how to hack the modern environment to replicate the ancient conditions. The viewer will learn to trap steam. The viewer will learn to manipulate thermal shock. The viewer will learn that the greatest ingredient in baking is not flour, yeast, or water. The greatest ingredient is the atmosphere itself. Have you ever pulled a loaf from the oven, tapped the bottom, and heard a dull thud instead of a hollow drum? Have you ever sliced into a loaf only to find the texture of a damp sponge? These are not failures of skill. These are failures of equipment. That the tools are lying. The machine is working against the baker. It is time to stop listening to the appliance manual. It is time to start listening to the physics of the year 1200. The investigation begins now. The investigation turns now to the primary suspect in the death of the artisan loaf, the modern convection oven. Marketing campaigns have convinced the global population that convection is a superior feature, a technological upgrade designed to cook food evenly and rapidly. For roasting a chicken, convection is a miracle. For baking a loaf of sourdough, convection is an executioner. The convection fan functions as a forced air dehydrator. When the fan spins, and the fan strips the boundary layer of moisture away from the surface of the dough. This creates a catastrophic event known in bakery science as premature crust formation. Visualize the dough in the first 5 minutes of baking. The yeast is frantic. The gas bubbles are expanding rapidly due to the heat. The loaf is desperate to grow, to triple in volume. But the modern oven has already killed the surface. The dry, moving air has turned the outer millimeter of the dough into a rigid shell before the interior has finished rising. The loaf tries to push against this shell. The loaf fails. The energy is trapped. The result is a dense, heavy brick with a tight crumb structure. The baker sees a loaf that looks cooked on the outside but feels heavy as lead. The baker cuts into the bread and finds large, erratic tunnels surrounded by dense dough, a sign that the gas tried to escape but was strangled by the premature crust. This is not a mistake in kneading. This is a mistake in atmospheric management. Furthermore, the modern oven is built upon a lie regarding temperature. The digital display reads 230 degrees Celsius, but this number is a fiction. The modern oven is a thin metal box insulated by fiberglass. The modern oven possesses almost zero thermal mass. Thermal mass is the ability of a material to absorb, store, and radiate heat over time. When the baker opens the door of a modern oven to load the bread, the temperature crashes instantly. The hot air rushes out, and because the thin metal walls hold no energy, the oven drops by 40 or 50 degrees in seconds. The thermostat sensors panic. The heating elements blast on at full power to compensate. This creates a scorching, radiant heat that burns the bottom of the bread while the air temperature is still recovering. The loaf is subjected to a violent roller coaster of temperature spikes and drops. The yeast dies too quickly or too slowly. The enzymes are confused. And the chemistry of the bread is chaotic. Contrast this with the medieval masonry oven. The medieval oven was not a metal box. The medieval oven was a mountain of stone. A village oven might weigh 5 to 10 tons. The baker would fire the oven for hours, saturating the stone with heat energy. When the fire was raked out and the bread loaded, the door was sealed. Even if the door was opened for a moment, the temperature did not drop. The 5 tons of stone acted as a thermal battery, irradiating a steady, gentle, relentless heat from all sides. There were no heating elements cycling on and off. There were no fans. There was only the black heat, the deep infrared energy stored within the thermal mass. This heat penetrated the center of the loaf without burning the surface. The modern oven cooks with hot air. The medieval oven cooked with radiation. The difference is the difference between drying a shirt with a hairdryer and drying a shirt in the sun. One is harsh and superficial. The other is deep and penetrating. To understand why the medieval loaf succeeded, the investigation must descend into the microscopic world of the starch granule. The secret of the medieval way is not magic. The secret is the gelatinization of starch. Flour is composed mostly of starch. In the raw state, starch granules are hard, crystalline knots. They are indigestible and tasteless. To become bread, these granules must unravel, absorb water, and then swell until they burst. This process is called gelatinization. Gelatinization requires 2 things: intense heat and abundant water. Here lies the critical function of the medieval oven that the modern world has forgotten: the steam phase. In a masonry oven, the baker would mop the floor of the oven with a wet rag or place a vessel of water inside before sealing the door. The massive stone walls would instantly turn this water into steam. Because the oven was sealed tight, the steam could not escape. The atmosphere inside the baking chamber reached 100% humidity. When the cold dough entered this steam-saturated environment, a miracle of physics occurred. Steam is a gas, but steam wants to return to a liquid state. When steam hits the cold surface of the dough, the steam condenses. This condensation does 2 vital things. First, the condensation releases latent heat of vaporization. Converting steam to water releases a massive amount of energy directly onto the bread, transferring heat far faster than dry air ever could. This gives the yeast a final, explosive boost of energy, maximizing the oven spring. Second, and most importantly, the condensation keeps the skin of the dough wet and elastic. Remember the premature crust formation of the modern oven? The steam prevents this. Now, for the first 10 to 15 minutes of the bake, the surface of the medieval loaf remains soft and pliable. The internal gas expands, and the loaf balloons outward without resistance. The bread reaches maximum volume. The ears of the score marks lift and curl beautifully. The steam allows the bread to reach its full genetic potential. Only after the steam dissipates does the Maillard reaction begin. The Maillard reaction is the chemical interaction between amino acids and reducing sugars that creates the brown crust and the complex, nutty flavors of roasted grain. In a dry modern oven, the Maillard reaction happens too soon, sealing the loaf. In the medieval steam oven, the Maillard reaction is delayed. It is held back until the loaf is fully grown. When the browning finally happens, it happens on a fully expanded canvas. The result is a crust that is thin, crisp, and glass-like, rather than thick and chewy. This is the secret of the hearth loaf. The medieval baker did not need a degree in chemistry to understand this. The medieval baker listened to the bread. If the crust formed too early, the baker knew the air was too dry. If the bread was heavy, the baker knew the thermal mass was insufficient. The modern industry attempts to solve this with chemical dough conditioners, enzymes and emulsifiers added to the flour to artificially soften the crumb and extend shelf life. They solve a physics problem with a chemistry set. They treat the symptoms of the dry oven rather than curing the disease. The medieval solution was pure physics. By controlling the state of water, liquid to gas, gas to liquid, the ancestor created a food product that remains superior to the industrial alternative. The crispy crust of the supermarket baguette is often a lie, created by drying the bread out completely. The true crispy crust of the medieval sourdough is a result of violent, steam-injected gelatinization, followed by intense, radiant heat. One is a dried husk. The other is a caramelized shell protecting a moist interior. The investigation has identified the enemy, the dry, low-mass environment of the modern kitchen. The investigation has identified the mechanism of success: steam, a thermal mass, and the delay of the crust. The question remains, how does a person living in the 21st century, without a 5-ton stone oven, replicate these conditions? How does one turn a cheap metal box into a steam engine? The answer lies in simple, brutal adaptation. The answer requires abandoning the baking sheet and embracing the vessel. The solution is not to fix the oven, but to build a smaller oven inside of it. The skeptic demands proof. The skeptic believes that the medieval way is merely nostalgia, a romanticization of a primitive past. The skeptic is wrong. The superiority of steam-injected baking is not a matter of opinion. The superiority is a matter of hard data. The investigation turns first to the laboratories of the modern food science institutes. A study published in the Journal of Cereal Science confirms the mechanics of the steam effect. The researchers measured the specific volume of loaves baked with and without steam. The results were undeniable. Loaves baked in a steam-saturated environment increased in volume by nearly 40% compared to loaves baked in dry air. The researchers also analyzed the crust humidity using electron microscopy. The dry-baked crust showed a chaotic, thick, and microfractured structure, evidence of rapid dehydration stress. The steam-baked crust showed a uniform, thin, and glossy structure. The science proves that steam does not make the crust soft. Steam makes the crust crisp by allowing the starch to fully gelatinize before dehydrating. Furthermore, the Norwegian Institute of Wood Technology, in their studies of thermal mass in traditional stove construction, have validated the efficiency of black heat. The studies show that radiant heat from stone or cast iron penetrates organic material more evenly than the convective heat of hot air. Convection heats the air, which then heats the object. Radiation heats the object directly. This explains why a pizza baked in a 400-degree electric oven takes 15 minutes and dries out, while a pizza baked in a 400-degree wood-fired oven cooks in 90 minutes and remains moist. The physics of heat transfer cannot be cheated by a digital fan. But the most compelling evidence does not come from a laboratory. The most compelling evidence comes from a tomb of ash. In the year 79 AD, the volcano Vesuvius erupted, burying the Roman cities of Pompeii and Herculaneum. The ash preserved organic matter in a vacuum of time. Archaeologists discovered 81 carbonized loaves of bread inside the oven of a bakery owned by a man named Modestus. These loaves, are known as panis quadratus, are nearly 2,000 years old. Yet the loaves tell a story of advanced engineering. The loaves are round and scored into 8 sections. The scoring is open and defined, proving the existence of oven spring. The loaves have retained a high vertical profile, meaning the loaves did not spread out into flat pancakes before setting. This retention of shape proves that the Roman oven of Modestus was capable of generating immense initial heat and steam to set the structure of the dough instantly. The Roman baker did not have compressed gas tanks. The Roman baker understood that by sealing the oven tight, the water inside the dough would create its own steam chamber. The artifact of the panis quadratus is a physical testament to a lost standard. And the Roman slave ate bread with a structural integrity that the modern suburbanite cannot buy. The bread of Pompeii is not just a fossil. The bread of Pompeii is an indictment of modern manufacturing. The knowledge existed 2 millennia ago. The knowledge was lost not because the knowledge was flawed, but because the knowledge was slow. Knowledge without action is merely philosophy. Knowledge with action is survival. The viewer now understands the physics, thermal mass, and steam retention. And the viewer understands the enemy, the modern electric oven with its dry, fluctuating air. The question becomes, how does the viewer defeat the modern oven? The viewer does not need to build a masonry oven in the backyard. The viewer needs to build a masonry oven inside the electric oven. The solution is the cast iron protocol. The tool is the Dutch oven. A heavy cast iron pot with a tight-fitting lid is the perfect simulation of the medieval baking chamber. The physics are identical. Yet the cast iron provides the thermal mass. The iron absorbs the heat and radiates the heat steadily, stabilizing the temperature fluctuations of the electric oven. The tight-fitting lid provides the steam trap. Here is the operational procedure for the modern medieval baker. The baker places the empty Dutch oven with the lid into the electric oven. The baker cranks the temperature to the maximum setting, 250 degrees Celsius or higher. The baker lets the iron soak in the heat for at least 1 hour. The iron must be saturated with energy. The iron effectively becomes a thermal battery. When the dough is ready, the baker performs the transfer. The baker carefully removes the scorching hot pot. The baker places the dough inside. Now comes the thermal shock hack. The baker drops 2 standard ice cubes into the pot between the parchment paper and the iron wall. The baker slams the lid on immediately. Now what happens inside that sealed iron chamber is a violent replication of the medieval physics. The ice cubes hit the 250-degree iron and flash boil instantly. The water expands 1,600 times its volume as it turns to steam. The lid traps this explosion. The pressure inside the pot rises slightly. The humidity hits 100% in seconds. The dough is now enveloped in a superheated, pressurized steam bath. The crust remains wet. The yeast explodes in a frenzy of activity. The loaf rises and rises and rises. After 20 minutes, the baker removes the lid. The steam escapes. The Maillard reaction begins. The radiant heat from the iron walls browns the crust to a deep chestnut perfection. The result, 40 minutes later, is not a homemade loaf. The result is a professional hearth-baked loaf that rivals the best bakeries in Paris or Vienna. The crust shatters. The crumb is open. The flavor is complex. The baker has successfully hacked the modern machine. And the baker has used the electric oven only as a heat source for the iron vessel, bypassing the dry air entirely. Now consider the mathematics of this rebellion. This is not just about taste. This is about economic independence. A high-quality enameled Dutch oven costs approximately $50. A bag of premium organic flour costs $5 and contains enough grain for 6 loaves. The cost of yeast and salt is negligible. The total cost of materials for one medieval standard loaf is less than $1. Compare this to the artisan bread sold at the boutique bakery. The bakery charges $8 for a loaf of sourdough. The bakery charges this premium because the bakery possesses the steam-injected deck ovens that the consumer lacks. The consumer pays a 700% markup for atmospheric physics. By purchasing the Dutch oven, the consumer breaks this dependency. If the family consumes 2 loaves a week, the savings are $14 a week. The $50 investment is recouped in less than 1 month. After that month, every loaf is a dividend. Over 10 years, the savings amount to over $7,000. This is the freedom tax. The consumer pays the tax for convenience. The craftsman keeps the gold for skill. The modern world tells the consumer that quality is something that must be bought. The medieval way tells the student that quality is something that must be made. The transition from buying bread to baking bread is a transition from dependency to agency. When the baker slices into that first successful loaf, hearing the crackle of the crust, seeing the steam rise from the open crumb, the baker is not just eating calories. The baker is consuming the fruit of applied physics. The baker has proven that the old ways were not primitive. The old ways were precise. The Dutch oven is a heavy, cumbersome object. It requires care. It requires lifting. Or it is dangerous when hot. This is good. The weight reminds the user of the reality of the task. The danger demands focus. The process anchors the human in the physical world. The result is honest. The modern historian often dismisses the medieval era as the Dark Ages. The modern historian paints a picture of ignorance, filth, and primitive suffering. The modern historian is arrogant. The modern historian confuses the lack of electricity with the lack of intelligence. This investigation into the physics of bread proves otherwise. The people of the past were not primitives stumbling in the dark. The people of the past were masters of applied physics. They did not have the luxury of waste. And they did not have the safety net of the supermarket. When the medieval baker fired the oven, the survival of the village depended on the outcome. The result was a technology of necessity, refined over centuries into a perfect cycle of energy and matter. The modern human lives in a black box civilization. The modern human pushes a button and light appears. The modern human turns a dial and heat arrives. The modern human opens a plastic bag and food falls out. The mechanism remains hidden, and the cause and effect are severed. This convenience breeds a profound helplessness. If the power grid fails, the modern oven becomes a useless metal cabinet. The modern human starves in a kitchen filled with appliances. This is not progress. This is fragility. By contrast, the medieval way is a path of resilience. The baker who understands the Dutch oven, who understands the thermal mass, who understands the steam, is no longer dependent on the black box. The knowledge resides in the mind and the hands, not in the microchip. If the electricity fails, this baker can bake in a wood fire. If the gas fails, this baker can bake over coals. The skill is portable. The skill is permanent. This investigation challenges the viewer to redefine the concept of wealth. The modern definition of wealth is the ability to buy. The medieval definition of wealth was the ability to make. The person who buys the artisan loaf is a consumer, as a passive mouth at the end of a supply chain. The person who bakes the artisan loaf is a creator, an active participant in the sustenance of life. The consumer is drained of resources. The creator is enriched by experience. There is a spiritual dimension to this labor. In the silence of the kitchen, waiting for the dough to rise, the baker enters a rhythm that is older than recorded history. The act of waiting is an act of defiance against the instant gratification of the digital age. And the modern world screams for speed. The sourdough screams for patience. To bake real bread is to step out of the frantic current of modern time and step into the slow, deep river of geological time. The stone heats slowly. The yeast ferments slowly. The crust browns slowly. In this slowness, the baker finds a peace that the smartphone can never provide. The challenge is now laid before the viewer. The viewer has two choices. The first choice is to close this video, go to the store, and purchase another bag of industrial foam. The viewer can choose to remain a customer, safe and soft in the illusion of convenience. The second choice is the harder path. The second choice is to acquire the iron. The second choice is to culture the wild yeast. The second choice is to accept the failures, the burnt crusts, and the flat loaves that will inevitably come with the first attempts. But know this, the first time the viewer pulls a perfect singing and steam-blistered loaf from the iron chamber, the viewer will never go back. The taste of that bread is the taste of victory. It is the taste of a code that has been cracked. It is the taste of the medieval way. The ancestors are watching. They are waiting to see if the fire has truly gone out, or if there are still hands capable of tending the hearth. Do not let the fire die. Do not let the skill vanish. Become the baker, become the physicist, become the master of the steam. The investigation is complete. The oven is hot. The rest is up to you.